is changing the future. Thank you so much for being here today. My name is Madeline Varela. I work with W2O Group, which is a local marketing communications agency where I lead our technology practice for strategy. So I'm happy to be chatting with you and this very esteemed panel. We will be live streaming today, so if you have any questions, please make sure that you use the hashtag Bell SXSW so we can follow along from those at home. Send us your questions. We'll be sure to try to address them at the end. If you're here in the room with us, there's a microphone in the back of the room, and we'll try to get all of your questions answered. So today we're going to talk about the near future of travel and the new frontier just above us in the sky. While roads are really complicated with 2D challenges and the legacy of human history and the sort of complicated mess that we've made of things with scooters, as any of you in Austin have seen over the past couple of days, the skies are 3D playgrounds to build an autonomous air fleet of safe, fast, and affordable transportation options. So hopefully we're going to get to address some of these issues today. So as I welcome these panelists, I just want to give us an invitation to give you guys a brief view into what your viewpoints are, a little bit of brief background, and hopefully some thoughts on what you're excited to talk about today. So let's start with Anil Nanduri, who we're welcoming from Intel. Can you give us an introduction?
I'm Anil Nanduri. I run the drone group at Intel. And at Intel, we've been doing drones for the last 4 or 5 years. And if you know, we've been primarily doing all these light shows with hundreds, even thousands of drones in the sky, creating wonderful animations. But we're also building, more capabilities around commercial inspections and drone technology to automate the process of capturing the data, automating it, and analyzing the data. And at the end of the day, the value of what that data tells us about inspecting a bridge or an infrastructure or an utility. Now, the technology that's underlying to that applies to all of urban air mobility, and been really excited to be working in part of this industry.
Teena?
Thanks. I'm Teena Maddox. I'm a senior editor at TechRepublic, which is part of CBS Interactive. And I've spent the past 6 years writing about various smart city and technology topics. And I've been very fascinated watching autonomous vehicles and AI just become the forefront of what I've been writing about. So I'm always curious to discover, what everyone else thinks about it and what we can do in the future to make it more feasible.
Scott?
My name's Scott Drennan. I'm the VP of Innovation at Bell, and we're actually working on the vehicles to make this vision come true, both in the form of the Bell Nexus, our air taxi offering, and also our vehicle called APP, the Autonomous Pod Transport, which could gather data or transport logistics unmanned throughout our cities. Today I'm really interested in talking about AI not only as kind of a real-time device to use on a vehicle at any given moment to make it smarter, but also as a system that can help us look at the product development life cycle from the moment my conceptual designer puts pencil to paper all the way to our final service actions on the vehicle and how to start that cycle over again for the next generation. So really interested in that discrete conversation and the broader conversation, ultimately leading to how the vehicles can be safer in those moments that we talked about, but also safer through the entire product development life cycle, because that's where really safety begins.
Great, thank you. So you guys all have very different perspectives and backgrounds on this conversation, and as we get started, I'd love to set a bit of a standard definition for how you think about AI in this context. And AI as a topic has really evolved a lot over the past 10, 20 years in terms of how we think about today's AI versus 20 years ago. And 20 years ago, what we thought about as artificial or augmented intelligence is today's feature set, right? So as we talk about this topic, I think it would be helpful for us to kind of set a standard of what is AI in transportation today. So from an individual perspective, in today's vehicles, could it be something like providing transportation guidance, or maybe it's safety features? Or from a collective perspective, when we think about smart cities and how the next generation of flight or up above us, how those flying systems, how do we need to think about AI in terms of providing infrastructure decisions? So where are we on the AI spectrum in your mind, and how would you define that for today's discussion? So maybe let's start with Scott.
Yeah, so I think from our standpoint, it goes back to these two moments in time for us. You know, the individual example here behind us is an active system that's needed as you're moving through space, say in your car, and it becomes a decision aid about the environment and the driver. And then on this collective system, it also speaks to what I mentioned before, this complete development cycle. But really, when you look at that picture there in particular, it talks about all the rest of the systems that want to link into the vehicle itself. So in our case, moving just from the operation of the vehicle, say moving from point A to point B, but how are we connected to new communication methodologies, say 5G, that's in the city as it is for telecom, but we could use it for our own purposes as well. And then how we interface between two areas really that are controlled by different entities. A cityscape below that is a part of a municipality, and the Department of Transportation that governs ground actions, and then the airspace above it, which is usually the FAA or always the FAA's environment, and how those two can speak to each other, and how we might take AI and make that more of an intelligent conversation, and really a digital conversation ultimately, because we want autonomy to be a part of this.
Okay.
Well, when I talk about AI usually, I mean, there's three components, and to me they're all part of the same picture. There's AI, artificial intelligence, there's machine learning, and there's deep learning. And they're really all part of any conversation that you have about artificial intelligence. And in the instance of transportation and a smart city, for instance, which is what I write about the most, so it's where I am most comfortable giving a comparison. For instance, AI in a smart city is that first level. It would be the data analytics, the raw data, the initial analysis that city engineers are making. When you step up to machine learning, you're looking more at specifics about the data, diving in a little deeper, figuring out where traffic congestion, where pedestrians are more likely to be between 5 and 6 p.m. So if you know there's going to be more people walking, more bicycles, things like that, more scooters, you can kind of plan for it and protect both the citizens and the folks in the vehicles. And then you've got deep learning, which is when you take all of that and just as it sounds, you go very deep and you're going to look at things for the future. Whether, okay, these roads are more frequently traveled, so we need to plan for road repairs, things like that. It's a big picture, and I write about each component of it at various times. So, and everything kind of plays a role. Just as Scott mentioned, 5G, different things like that, and everything can kind of be seen from that perspective.
And I think this is an excellent topic, and I think we break down what AI really means. And you think about automation, and you combine automation with some intelligence to it. And then the level of intelligence, or you can call it self-governance as well, so that you're independently operating. And you can give various examples. Now, you could say a tire sensor that tells you this is your pressure in your tire is an automation equipment. But a sensory system that tells you it's time to replace your tire is an intelligence. And how does that allow you to take that learning and give you an inference is where the concept of AI comes in. And how do you do that? You take a series of automation, you learn from it, and you train it. And once you got a certain primitives to train, and then you're able to then apply it into an inference. So it's a continuous learning process. And the journey we are in is trying to take a level of automation into levels of autonomy. And eventually, the amount of human dependence and that intelligence that is going to get applied to it gets more and more smarter over time. And that's the concept and the principle. It does not mean that the system is driving on its own and it's taking a world of its own. It's about how the self-governance rules are evolving over time. And so that's the concept of AI, that is about how do you learn and how do you apply the intelligence and how do you make that intelligence into a framework.
So that brings up an interesting question then. Who is creating some of those self-governing rules? Who starts to set up those frameworks? And how do you manage that system in a way that benefits the collective that you were talking about with these systems that have to work together? Because it seems like you have a lot of independent groups and individuals that need to participate in order to make all of this work.
And this is where technology, and again, Intel being a technology company, really how do you leverage technology? Where humans are really good at is making the decisions with the set of abstract inputs that we get. But where the systems are really good at is to organize and understand large sets of data on a consistent basis.
Okay.
So how can you take that ability for infinite storage that's coming up with all the data that is being ingested in the systems? We're talking about terabytes and terabytes of data. How do you use computing technologies and algorithms to help process that data? And then how do you make sure we can create then inferences for the kind of put it in a format for human intelligence to actually be smart about it? What we cannot do is look at 30 sensors at the same time. What we're really good at when someone has actually taken the 30 sensors, distilled that information for us to process. So that's why we are having these conversations. Where is that line of, okay, the governance rules that we will be setting up versus what we govern as a standard and the technology does. So that's the line that we're trying to do.
Okay.
Yeah, we've been thinking about that connection to the pilot in most of our applications. You can imagine their world is full of data, just as Anil described, and oftentimes it can be too much data. And two of the goals that we have at Bell are to make our pilots into two simple things: safety officers and mission officers. And all the rest, if we can help them with fly-by-wire to have easier and more intuitive flight controls, great. If we could help them with AI, we'd like to do that as well. But that goal is to give the dumb, dirty, dangerous, and dull pieces of all the actions that can happen in a helicopter flight or any other kind of air vehicle flight, hand it off to something more capable of handling that type of interface, and let the pilot be those two things: safety and mission officer. And these pictures remind me of the dynamicism of the road and the air. You know, I think from the timeline of AI in my mind, where you always heard about, well, let's play chess with AI and see who wins. And no matter how complex that state of data is in the chess set, it is finite in the end, and the system has to be smart to navigate all those moves. But you can imagine a system like we see on the screen behind us, where you just never know what the scenario is that's coming your way, and that augmentation of the human intelligence or the input that the human programmers put in the system to begin with should be able to navigate more dynamic systems like this.
I wanted to say, the idea of innovation, whenever something comes out and it's new, scares people. I mean, obviously when the car first came out, people were scared of that. When unmanned elevators first became the thing, you know, people thought that was just horrible, the idea of having to be in an elevator without someone to help you. But what's most interesting to me is I go to a lot of conferences and listen to a lot of experts talk about these things, and just the role that regulation could play in kind of slowing innovation. And, you know, it's a balance, and it's very interesting to me, but it's something that I look forward to, you know, learning a little bit more about as we go.
Mm-hmm. There's actually a policy session coming up later this afternoon where we're talking about the role of regulation and policy in innovation and how those work together. And you know a little bit about that with FAA and,
Yes.
and NASA seats. So just a little bit of a hand raise here, and hopefully those online can participate as well. So what do you all think? Do you think that AI is going to increase the safety of air transportation in the near future? Little hand raise here. Yes? Yes? All right. Nice little 95% of the room. Yeah, thank you. All right.
Oh, yeah, I wanted to say we have a Twitter survey right now on our TechRepublic Twitter site, which is at TechRepublic. And if you want to go and log in with your phones and vote, at the end of this session, we're going to tell you guys what people, what the majority think. And the question is simply what Madeline just said. It's, do you think that artificial intelligence will increase the safety of our transportation? So we're really curious to find out what the majority, not just you guys, but what the live stream public and everyone else thinks.
So I'm curious to get a little bit more on the specifics here and talk about how AI is creating safer systems. So we have a lot of data coming in, and there seems to be a lot of signal and noise conversation here, where you have a ton of input, and we've talked about how we have to create systems that discern the good and the bad in decision making. How do we go about creating systems that can make good, qualified decisions in these types of situations to create safer environments? And what are the factors that we have to keep in mind in order to create safe environments for all involved, not just drivers or pilots, but the entire environment?
Yeah, so this one actually, we kind of break it into three parts of it, right? The first part, when we talk about aviation and the flying systems, one is what the system behaviors itself and the flight control and the capabilities, where the sensory inputs and the technology that's happening. How do you make the pilot, whether he's on board, remote, or it's fully autonomous, that's going to be a journey. How do you get him to distill all this data about the flight itself? Then there's the environment factors. How does the system know what's happening around me? So if you're talking about an eVTOL and you have to land, and there's, you're landing out in the open or in a vertiport, is it safe to land? What are the constraints? Is there another vehicle below me, or there's like people walking? How do I be able to distill information around my environment? Are there other systems next to me? And then there's the whole system view of it, is, okay, how am I managing that at a system level, coexisting with all kinds of traffic, and how am I able to interact with all the three? And then I would say there's another category of the variables like weather and environmental variables that come in too, which in some ways can be looked at as, I'm looking what's around my system. So these pieces of data can be structured, and you're getting all this information. And if you break that into an AI process or an intelligence process, there's intelligence on the system, and then there's intelligence at the infrastructure level. And both of them very, very tightly coupled with strong communications between the two to create that safe environment. So end of the day, the whole motivation behind it is to make it safer. And that's with that philosophy, you can build the structures around it.
Yeah, I think I'll go back to my introductory statements. We'll take an example of that real-time need for safety. You're out flying. Let's say there's two autonomous vehicles that look like they're going to interact in some way in the airspace, maybe even an autonomous vehicle and an unmanned, and you need some sensors to detect what is that interaction going to be. Is it a vehicle out ahead of me? Is it a bird? Is it a static subject? And then that intelligence can determine maybe what the relative speed ranges of that other entity in the airspace could be or are from direct measurement, and then link into the system on board the aircraft under your control and help you make decisions about maneuvers that could move the vehicle from one place to another and avoid the obstacle. And there also should be a communication link to that other object, and that if that object has a pilot on board, that might seem simple, but it's more involved than we think. There's speech involved or digital signals involved. It could be an unmanned system, so there's some type of relay between the two, and then hopefully the intelligence on that system can link with the intelligence on the initial system to make that interaction safer. Two different paths, both that deconflict the situation at hand and make for the continuation of the flight, the finishing of the mission. The other one is, for me, when we think about safety, we have to think about it every day at work and what contributions we make as an engineer, a technician on the shop floor, a maintainer out in the public when the vehicle's operating. So if my engineers, whether conceptual, pre-design, or detailed design, are less intelligent about how to make a wing that is strong enough and safe enough, then we're at risk. If we go into the shop and we want to build that wing and our technicians are less intelligent about the process that they have to apply to make the safest wing, then we're at risk. And then out to the operational world, if our maintainers are less intelligent about, well, I have to re-torque a bolt or reconnect the wing or service the joints between the wing and the fuselage, and they don't know how to do it or are less intelligent about doing it, we're at risk again. So I'm using this idea about those players being less intelligent, and of course we all believe we have the most smartest people possible on all our teams, but there are moments in all of those scenarios driven by fatigue, an abundance of data, maybe pressure to rush and get something done. All natural phenomenon inside the business of design, build, produce, and field air vehicles. And so we kind of owe it to each other, and not only those four individuals I've described, because they're all very responsible individuals and they care for the product that they create, but then all the individuals that are going to be inside the vehicle itself, be underneath the vehicle when it's flying, and then just really the folks experiencing it from a distance. You don't want the public, no matter how far away a vehicle might be or how distant it could be to their direct interaction below, to think in a negative way about a system like this, because we really need the whole entire community to come up behind it and believe in it. And the deeper you plant the intelligence in the process, the more confident we can all be as a community in how these operate and serve us.
So I know, Teena, you've been doing a lot of work with looking at how smart cities can create roadmaps to reduce risk, and done some research with the East-West Institute and looked into this a bit more. Can you share any of the findings on what they have shared that could be relevant in the types of risk reduction that Scott has talked about, and some of the risk reduction elements that go into creating a safe environment holistically?
Absolutely. One of the things that's come up a lot in smart city coverage, I remember I did the first story on this exact topic about 4 years ago, and it's still one of our most popular articles, but it's what cities need to do, city officials, to create a smart city. And the first thing is create a plan, create a roadmap. I recently did a story on a study that the East-West Institute had published, and they outlined 4 key things that city officials need to pay attention to in order to create a safe environment for citizens and to make things run efficiently. And the first was cybersecurity, and that's things such as, as simple as making sure that IoT devices are secure, whether for city employees or people within the city. The second is cyber resilience, which has become more and more important as we see, climate change and weather disasters happening, and cities don't have the redundancy in order to keep everybody connected during a situation like that. So the first 2 steps would be the cybersecurity, then the cyber resilience. And the third is privacy. The East-West Institute actually recommended that cities hire a chief privacy officer in order to be completely transparent, and that periodically they share data with the state as far as how they're protecting the data of citizens and how that's being used. And then the fourth step was data protection by the government. So it ties in a little bit to the third as well, but they did break it out separately. And that was simply the city communicating to all of its citizens what they're doing with the data and how they're protecting it. So, and the key thing was simply that cities do need a roadmap to reduce risk and to make cities safer and to make them smarter, frankly.
Right, because it seems to me that when we talk about safer in the skies, it's just as much about vehicle design, the safety of the elements that we're creating for safety, but the data that we're talking about here, there's a tremendous volume of data, compute data, IoT integration, all of these elements that is going back and forth. And if you don't have a plan for that from a privacy perspective and a cybersecurity perspective, as well as from an IP perspective with your design, and how to manage all of that, there's a tremendous role and opportunity that AI can play in that element of safety as well, to make sure that all of us are safe in this environment too. What is that? How does that play here?
Actually, this is a great point here, and privacy and security are two that we always think about it as an after fact, but it's foundational in every part of the work that the technology is going to be built on. And so that's a very aspect when I talk to my architects and we say, you know what, hey, how is privacy and security actually built into the system as compared to you kind of design the system saying, okay, how do I deal with privacy and security? Now, on privacy, there's actually good policies in place. There's NTIA that has actually put the best practices. And again, the balance between what is regulated is what the industry consensus can come up with. The more there's consensus in the industry and actually putting a framework out there and standardizing around it is actually a much more faster and efficient way than trying to wait for someone to put rules on it. So this is the balance between industry and regulation on how you can get that best practices involved. And this is going to be everything. Both of these are fundamental to what we look at as the safety of the overall aspect of it. And if you look at how it's evolving, I mean, we see Street View and the technologies like that, and now they've actually used software and intelligence to anonymize the necessary data. So that's how you see AI come in and start to help build out, saying is that, okay, what needs to be anonymized, what can be shared, and how do you build that learnings? Because end of the day, there's information that's valuable to make the system safer. You want that information. But what's the information that is more relating to privacy or security? You want to be able to abstract it out. So how can you use algorithms to then help distill that information? One thing for sure, as we are looking into the future, there's just going to be more data, more sensors, more information. And these conversations and these stages of evolution on the privacy will continue to happen.
Yeah, a couple of things come to mind for me. We do this fun exercise at work a lot for when we do our aircraft and system safety analysis. You always start by what's the safest way to go about this, and the answer is always the same: stay on the ground. But then suddenly you realize that well, then we're not transforming society anymore. We're not transforming mobility if we actually choose that true safest state. So you get into this balance that Anil mentioned, and it applies to the information that's out there. So you say, well, what's the safest way to protect my data? And the answer would be, well, don't take any. Don't take pictures. Don't let sensors look around in these environments. But you can't, because then again you wouldn't transform mobility. So it's interesting to kind of play that intellectual game up against all these various sectors that you mentioned, Teena, with cyber and the privacy and protection of data itself. What is that right balance between doing nothing and therefore not advancing, or doing something in the right way? It's interesting too to think about how so many different aspects come in. I mean, we love to focus, as everyone said, just on the vehicle itself, but as you interact with communities in ways that we've never interacted before, it really opens up your eyes to the concerns of the community itself. We often get asked the question, well, can't you do this already? You have helicopters. And there are helicopter air taxi services or helicopter logistics services. But when you look at some cities like New York or San Francisco, they can be relegated to very specific areas. In New York, you can only operate, around the island of Manhattan, really. Out in San Francisco, maybe only for emergencies that involve, maybe a medical emergency or a police emergency. Well, now we're trying to say, well, no, everyone can have this service. And so when you get into that bigger word of everyone or the public, you have to really sit down and listen carefully to all of their concerns that will ultimately go way past the kind of basics of what Bell does, which is make the safest aircraft possible, and listen to the other concerns that are there.
I wanted to say one thing about the data and the security and privacy. I write a lot about that. And I remember I did my first in-depth story on that. It was 5.5 years ago. And even at that point, I talked to so many experts about it, but there's all this data being collected on, the vast majority of us. But even if you've decided to opt out, say you live in that cabin in the woods in Alaska and you don't do anything online, anyway, you still have a data profile. Yep. They still know who you are. I mean, the fact that you're making those choices, it still is completely, it's a different path of how you're perceived and how you're seen. There's data on all of us, so.
Yeah, so it's all what we do with it, right?
Right,
Yeah.
so I find that just fascinating.
Or what they do with it. Who is the they, right?
Exactly.
So how is let's shift just a little bit. How is designing or managing AI different for flying vehicles than it is for ground-based vehicles? What are the considerations that are different? What are the rules that we have to deal with? And how do you take those considerations into account when you're thinking about things like the rules of the road, as it were, in the sky versus on the ground? I know that you have some experience with this in spatial orientation with smaller vehicles,
Yes.
right? You have some experience with larger vehicles, and I know that you've been studying how this interaction happens altogether. So I'm curious to hear what you guys think in terms of how AI can play a role in managing how all of this future traffic will work together and what we can learn from current traffic.
I'm really optimistic about the skies in this regard. Although the ground has kind of kicked us off, or so it seems, I think there's a couple interesting points to be made. First, I think it's easier in the air, and I'll go into some of those. Second, I also think there's more autonomy in the air today than you realize. Many of you have flown in to Austin to enjoy South by, and there wasn't a lot of hands-on time on that flight, and we don't actually think about that too much because there is a pilot on board, and therefore we think, well, they're controlling the whole flight, but they're actually using automated and autonomous systems to help with that. The reason I'll go back to it's easier in the skies are a couple things. And this is not to disparage the ground operations as well. We need both of them. But in the sky, the moral conundrums are easier. They are contact and non-contact. It's much more binary. So it's always an avoid scenario. There are very few, because there's a lot of space up there, and we're going to shrink that down a bit, but there are very few moments where you might have a system looking at a shopping cart, and the famous example that people use, the baby carriage, and saying, well, that has 4 wheels and that has 4 wheels, that has this handle that someone's pushing and that has a handle that someone's pushing. What happens, and how does that decision get made in that moment? We don't have that challenge in the air in the same way. The other interesting piece for me too is in the initial states, because oftentimes we talk about technology and we think, well, it's just going to instantly be here. But what we're learning on the ground is there's actually an interaction between autonomous systems or unpiloted systems and manned or piloted systems that can present difficult challenges for artificial intelligence just in and of itself. And when you extrapolate that to the air, that will exist too, but my easier bit is that it took me all of about an hour to get my license to drive an automobile, and I would say that leaves me as an amateur pilot on the ground, whereas pilots in the air are consummate professionals. And so these initial interactions of unmanned systems with manned systems or unpiloted systems with piloted systems should be much cleaner in the air than they would be on the ground, because the rules of the road in the air are well defined, well understood, and adhered to very strictly by the manned entities that are out there. And then the third piece is really just look up at any, when we leave this room today, there's a lot of space up there. And so we have a lot of room. We have a third dimension to maneuver in. We have vehicles that are quite accustomed to doing those types of maneuvers for perhaps other reasons over in the military side, but we can pull a lot of that over to the commercial side to help us be ready to take advantage of that third dimension. So I'm pretty excited about that. An optimist. I think the rules of the sky are more defined than the rules of the road, and that encourages me to think that the intelligence that we add to it can really deal with that.
And just a super quick follow-up. I would assume, and some of what I've been reading, is that the vehicle communication systems and some of the automated systems for space management within air systems are much more sophisticated than what we have currently within road-based vehicles. Is that accurate? What do you think about that?
Yeah, I think so. I mean, when you're talking about the national airspace, again, there are specific rules about flight, about communication. There are specific bits of data, and I'll use that term to make the transition again to the unmanned. There are bits of data that transmit from the pilot's mouth to the tower, let's say, and they mean discrete things that, albeit it's a human on the other side that absorbs the information and takes action, I'm again encouraged by the discrete nature of the information that exchanges hands, because everyone gets worried about, well, how do these computers interpret voice data?
Right.
And there are challenges there, linguistic challenges, accents, maybe someone who uses more ums than the next person. But I think the core information with the right intelligent system on top can be extracted out and communicated in that same discrete way to the towers for unmanned vehicles to act. So I think, again, I'm encouraged by that discipline and sophistication that's up there in the air. And I'm not saying it couldn't be available on the ground, but I just see a lot of other contingencies. We were at a fun intersection in San Francisco recently where I think the humans actually got trapped. It was one where there were two crosswalks. You couldn't make a right-hand turn, and the light seemed to be just perfectly timed so that you would, if you didn't kind of push the rules a little bit, you might sit there all day and you're looking out trying to time where the people are, and then take the right-hand turn when you had your opportunity. But I think in the air the answers are clear.
Right. So in a current autonomous vehicle or semi-autonomous vehicle as they currently stand, you would be stuck. Because with the people walking, it's just never going to go.
Yeah.
So, I mean, if I could chime in, there's, and adding on to what Scott says, there's one element in the third dimension that we leverage is GPS. And GPS is based on a technology where you have multiple satellites. Now, if you really go down to the geospatial experts and you look at GPS today, what we have in our cell phones, and the accuracy of that is in an order of magnitude of meters. It's a couple of meters plus minus, you can debate about it. And for ground-based management of that information, it's not accurate enough to have that precision you need. But once you go up to the third dimension and you're looking at, hey, I'm 2-3 meters away from each other, it's actually plenty of, you can put the constraints on those rules and saying that's accurate enough for me to do many, many things because we are not flying that close. And the greatest example for us is, just 4 years back, right? We could fly, 50 to 100 drones in the sky in an animation, and today we fly 2,000 drones. And we are using GPS technology, and we've got more efficient about how you're using the rules and how you're keeping the distance of separation, and yet giving this brilliant, automation in the sky, if I must say, because you cannot manually fly at that precision. But I can use technology to give me those, flight animations. And that's fundamental to how we are trying to expand this over where the third dimension helps us, is that we can use the technology of today to get this better in a framework to bring forward progress to revolutionize mobility. And needless to say, on the ground, they're doing their work to improve that precision, and that's where the autonomous driving is happening. And they're going to help us have more efficient use of space. And here we are talking about transformation and taking the future of mobility in a way where, hey, as we get more and more denser and these urban cities grow up, how can I then leverage this? Now, the reason why we are able to do this at a faster rate, and this is where I see what AI is really building us. And you talk about machine learning. These machines are teaching us with data. And that's what allows us to do this faster. The compute technologies and the technology for processing all this information is getting faster. So that ability for us to leverage that technology, learn faster, and then apply it faster. That's why you're seeing this pace. And that's in the next decade, you're going to see this transform so much more faster than the previous 2 decades. It's, again, because of this access to the technology that's allowing us to do so much more.
One of the things I get asked the most every time I write a story about autonomous vehicles and AI is it safe? And I know you guys get asked that a lot too, but it's really fascinating to me because people don't ask that in the cars they're at. I mean, and going back to Austin and the scooters again, here we are on the ground level, and there's something new thrown into the environment that isn't anticipated. I've been driving a rental car in a strange city, and there's scooters everywhere, and they're shooting in front of me, so it doesn't feel safe to me. As far as when it's an autonomous vehicle on the road, it's going to already be able to be aware of that, alert of those people, toward those people, and it'll be a little safer. And then the same thing with air transportation. I mean, I'm very excited about it because I can't wait till, Uber Eats can deliver my food to my door and I don't have to go out. But it's just, to me, I see both as, very possible and exciting, and I'm looking forward to writing about it more.
Excellent.
I think one of the things we think about too in the skies, and it's maybe a good point to mention it as well. We talked about how when you come in on a major airline, there's less touch time than you think between the pilot and the machine. But these skies we're talking about, it's not the wild, wild west. I mean, I think everybody knows the Blade Runner and the Star Wars scene, and there's just this preponderance of vehicles that seem like they're doing anything they want. But if you really looked closely today, there are established corridors for major airlines. There are established corridors today for helicopters, and we're starting to build up established corridors or sections of airspace for the smaller drones, and that learning will carry over. So you can make or envision corridors in the sky or tubes in the sky, and we'll have a certain amount of traffic and separation in one tube going from Austin up to Dallas or Dallas to Fort Worth. Then we'll have another corridor that's going the other way. And now we're in this kind of, we have lanes. Well, now that third dimension, it'll be at a certain altitude that's below or above the other two pieces of traffic. So those things exist today, and we need to build on what we know. And I think that's the foundation of AI, right? You got to build on what you know and give the system a model. So it would be quite a shame for us to just throw away the historical data that we have to use and teach these AI models, and it would be irresponsible. And really, it's something too that when you're trying to solve a problem, you want to use a green space to let your mind free for innovating, but at the same time, not forget about all of the legacy and history that's been there as well.
Can I ask a question? Because I was curious. This is something I was reading. Okay, the reporter in me is always coming out.
Yeah.
But I was just curious about, the time savings, because car versus, air travel. So if you've saved, I lived in LA and I traveled 2 to 2.5 hours each way to get to work. And I know right now, I think Washington, D.C. has the longest commute in the country at right about 60 minutes, but that's round trip, so that's a joke. But so that seems like a big component. You'll have a better quality of life if you do air travel versus car, it seems, because you're going to spend less time commuting. Yeah,
as long as we make it economically viable for more folks, I think that's a great point. So you two haven't been down to visit me in Fort Worth yet, so I bribe people into a simulated ride that we do oftentimes for visitors. It's from the DFW airport to Frisco. And Frisco is a really large growing town just outside of Dallas. That trip in rush hour traffic can take you 1 hour and 15 minutes. And when we fly it in a helicopter at the same speeds that our air taxis would go, it takes 8 minutes. Wow. And the other interesting part about the trip is when we get clearance, we actually split the airspace, the airport, in half. And we go right up the center. You can oftentimes look to your left, see a 777 coming in, look to your right, seeing a 787 come in. They land, we turn, and then we start our stopwatches from the terminal there out to Frisco, and it's about an 8 to 10 minute ride instead of 1 hour and 10 minutes. And I can't imagine, my kids are here today, the value that I might place in having more time with them than I normally do, because my commute locks me up on the front end and the back end of what I'm doing.
So, are your kids going to need to learn how to drive a car?
I don't know. That might be up to them. I know their uncle has never owned a car in his life, living in New York, so he's into public and alternate modes of transportation. I'm thinking they'll be even more so.
All right. So I want to come back to something that Anil was just talking about. You might have one of the coolest jobs in the industry in terms of bringing the public and drones together in a really fun and beautiful way with the Intel drone light shows. I'm pretty sure that everybody in this room has seen them at one time or another, from the Olympics to everything else, right? And the tech in those is more complex than meets the eye, right? I think we have a video to share that shows a little bit about it. So what I want to ask while we're getting this set up is if you can tell us a little bit more about the data and all of the other complexities that go into this, and what you've been able to learn over the years from these light shows and from these drones and how they interact, that you can apply to these bigger smart city problems that we're trying to solve here. So let's watch the video and then we can come back to that.
We're missing the audio.
We can all hum along.
So, yeah, thank you. Now, I mean, this is something we look at, and I think what Scott highlighted was about how do you make it simpler for, you'll be surprised. The pilot there is a computer, but we have a person sitting on it, and he has 3 buttons: launch, land, and any emergency light up or maneuver, and saying land immediately. And so the everything behind that is system generated and system trained, and we learn. We understand the state of the system. We understand how much of battery is left in each system. We know how many satellites and what's the GPS reliability for each system. We know, how often have the motors been used? What's the lifetime of that system? How long they've flown? When is it due for the next service? So the whole, think of it as a system level. And again, we are looking at 2066 drones here, whereas an operationally takes about 5 people to set the whole show up and just 1 pilot to fly it. Right, so that complexity of removing it from the person, letting the computer manage all this data for me so that we do what's best for us, is to be able to understand it from more at the solution level, and at the point of view that, hey, and as a pilot, he's more focusing on environmental factors. Hey, is there a helicopter coming? And then I need to take an action. As per the rules, if a helicopter comes in the middle of a show, our responsibility is to ensure that we land the drones. And so being able to have that clear presence of mind to make those decisions, that's where the pilot really helps. And so this technology, and you can see that evolution from the start of it is only 4 years, right? And that's the pace at which we are at. How do I take this concept and scale this at a much more larger level? And being able to have a fleet of these drones to be able to be managed, to be able to take it to urban air mobility, or for doing search and rescue, or to doing deliveries, or even for that inspections. How can I do this on a large-scale system? And this is where we were talking earlier. We need of course, the regulations are a key element, but the infrastructure, or the UTM, so this is the air traffic management system, again, also has to be a computer. It cannot be a person monitoring every drone. It has to be a system monitoring and letting a person know when he sees a problem. He's saying, hey, these 2 corridors or these 2 drones are coming closer. This shouldn't happen. And then the person can then take an action saying, hey, you know what, I can recommunicate to the drone and say, okay, one of them has to change course, or one of them has to, or communicate back to the drone system that, hey, something's happening here, take an action. So that interaction is critical. The other thing we learn here is, if I had to say where my challenges are, and from the learnings here, we do rely on GPS a lot. And when we flew at Super Bowl, we were flying inside the stadium at Atlanta with the roof closed. So there was no GPS. And so how can I manage that scenario that if I don't have GPS, how will my system behave? So there's still a lot of work that needs to happen in that scenario. The third thing, which I see still is a lot of work that we have to do, is the reliability of communications and interference. We are relying so much on radio technology. What happens if you fail in the radio technology, and how do you handle that situation? So these are, by the way, there's a lot of research going around here on those fronts, and these things, as part of safety, we continue to have to solve. But what keeps me, really optimistic is the progress that people are acknowledging those situations, those problems, and actually putting research and work into how do I handle it. And there are sensors, whether it's vision-based or radar that's getting much more smaller, or be it LiDAR technology that's getting miniaturized. So there are a lot of innovation happening and miniaturization happening, and that these sensors will help these systems get safer. So it's really a fun time, and having the ability, yes, it's a very fun job, but more importantly is to see how we can scale this.
Right.
And I think that's the journey we are on.
Very cool.
That's why I love these videos, because the only thing I can see as I watch that happen is it being applied to an air taxi or an unmanned logistics system. It's all there. And the engineers will figure out, well, because there's a person on board, maybe a little more reliability, but the fact that the foundation of, was it 2066? 2006, in close proximity to each other, changing dynamically quickly to form, complex messaging, that system is the foundation for the future of these safer skies that we're talking about, and in particular air taxiing and logistics. It's just incredibly exciting for me because it's there. That's
So I want to be sure that we have time for questions, if there are any. So if you have any in the room, if you can make your way to the mic in the middle of the room, and if we have any online, we'll take those. I know we have a person in the room who's going to help us out with that. So we'll give a minute for folks to make their way over there. And in the meantime, I want to make sure that we grab some closing thoughts from you guys. So Scott, if you have a closing thought on what you're excited about for the next couple of years.
Yeah, I think, our mission at Bell is to focus on safety, bring safety to our customers, and I know that AI is going to make that better. I mean, when you look at how things happen today, it's a battle of tons of data that we all need to use to get our missions done, and sometimes that data is too much, and AI can do nothing but help us there. So I'm really excited about not only the future of all these different mobility systems, but how artificial intelligence can make them real for us.
Right, and as a senior editor, I just look forward to being able to write about it and finding out what Bell is going to do next and what Intel will be doing next and sharing it with everyone. Because, I'm a writer, but I'm also a consumer and a citizen, so seeing how it's going to change my life and the life of my children is, a pretty big thing. So it's exciting.
I'm working at Intel, where we're looking at technology, right? We want to apply technology to solve the next world of problems, and moving, urban air mobility, moving autonomous driving, and using the computing as the intelligence block. And we talk about AI. End of the day, AI will run on technology and computing. But it's not just that. The communications that need to go with it, the storage and the onboard computing versus the, on the cloud-based computing, and how they interact together. And the prime objective we all have is one thing. How do we make this better for the humankind? And how do we make it safer for us and more productive for us? And that's the journey we are on. And that's we call it the North Star we're looking for. And along that, we learn. And just like AI is learning, we are also learning, and we will continue to evolve. And the best way is build, iterate, and learn and improve. And that's the constant process of evolution. And that's the journey which I like to be proud of and be part of, and really excited to be part of. And so again, today we are looking at this in 2019, and in 5 years from now, you'll look back and wonder, oh, it's only been 5 years, and here we are.
All right, so let's take our question.
Hi, first of all, thank you very much for a fascinating panel. My name is Greg Matthews. I'm from here in Austin. And the question I want to ask is about, I guess, the responsibility that each of your companies will have in the future for ensuring that technology is used for beneficial purposes as opposed to detrimental ones. Certainly any technology from the wheel on can be used for good or for ill, but as we get to truly advanced technology, like the kind that we're seeing even now, I can imagine, a fleet of drones being used for really nefarious purposes. And I'm wondering if you see in the future corporations having more responsibility or accountability for ensuring that those products are used only in ways that are beneficial or in ways that they're intended.
Well, from Bell's standpoint, we're really trying to transform our societies with air taxi and unmanned logistics systems. And so we start there, from the good cycle of moving people in different ways, from their homes to their business, from businesses to businesses, helping them get their goods in a more efficient fashion. And so, we don't even consider the nefarious uses of it. We just take it as a challenge to protect the people that we're serving with these systems itself. We talked a lot about cyber, so that'll be first on our mind, that these systems cannot be taken over by outside agents. They just can't be used except for the benefit of the customers and the communities that they live in.
And I think Scott nailed it. And the point comes down to is we have to look at the technology and its applications and the value it gives us. And as you see, you look at drones and hear stories about a hiker who's lost and he was actually found using a drone. I mean, you look at the light shows and the display in the sky, which nobody could conceive of probably 10 years back. I mean, you've got to start to focus on the value and the benefits that they bring us. And of course, there's always the conversation about technology being used for nefarious use. And our job here is to put those capabilities and frameworks, and this is where regulation and the social acceptance, as well as the conversations that help us put those boundaries. And that's the best part about the human race. Our ability to take that technology and apply it for good is within our domain and how we use it. So again, everybody has a role to play in that, and we continue to move the technology forward.
I think there's also a lot of conversation going on right now about the ethics of AI design, and the fact that we're having those conversations in this part of the process is incredibly important, and the more we talk about it, the more people are aware of it. And that's very heartening to me, that we're all at the table talking about these things now. All right. Any other questions?
Jeffrey from St. Paul. Many, many years ago, we flew Chinooks, and we had internal blivets, and we used compressed air for water landing. We did some creative things. Is Bell looking at any opportunities to recapture cargo weight, passenger weight through fluid dynamics or through air to utilize opportunities for in-flight movement, for power or other sources?
Right now, we're really focused on more electric VTOL. So you'll notice our Nexus vehicle uses hybrid electric, a combination of a gas turbine and electric components to drive the aircraft. Our smaller vehicles are all electric vehicles that use batteries. So right now, we're primarily focused on the more electric aircraft. Of course, pneumatics and hydraulics are used in some of the systems, the primary systems in the vehicle, whether that's actuation or otherwise, other control mechanisms. But most of our focus from a propulsion standpoint is on more electrification.
Hi. I can't imagine that when you started planning this panel, you'd expect the president to tweet about the subject this morning. I imagine you saw that, but he contradicted almost everything we've heard here today. I wonder if you have any reflections on that.
Well, I haven't seen the tweet, so maybe I'll catch up with you later.
It's short, but I'll just paraphrase it.
I walked right into that one.
He said, airplanes have gotten too complicated, they're more dangerous, and simpler and older is better.
Well, I think all engineers strive to make simple and safe systems, and we'll continue to do that at Bell.
All right. Any other questions? Okay. All right. With that, we want to thank you all for attending today and for joining us on the live stream. We'll be up here for a couple of minutes after the session, and thank you all for joining, and thank our panelists.